Behind me is the house I've grown up in. It is not connected to the electrical grid, and my parents built it themselves. In this 6-part series, I'll be looking at the different systems which make the house function. The first one, which I'll be focusing on in this video, is the electrical system. The main source of power for our house is the solar panels you see out there. These provide the vast majority of the electrical power we use. Though they are not tracking panels, we do adjust their angle with the season to make them more perpendicular with the sun to get a larger percentage of the light to make energy. When my parents first built the house, they originally started with just the solar panels over the door. We've added more as time has gone on, and we've needed to use more electricity for our freezer, and then later the last panel we just added as a convenience. We also have a small wind turbine on top of our house. It doesn't produce that much electricity, but can be helpful in times when we have a lot of clouds, but there is some wind. Our backup is a gas generator, which we only use for a few hours each winter, generally near the end of December or the beginning of January. Some winters we get away without using it at all, particularly with the new solar panel. This wall is where almost all of the components of our electrical system is. The power comes in from the solar panels through these 2 wires and into a circuit breaker box. There's one set of panels on each of these switches. It then goes into the charge controller. The charge controller serves multiple purposes. Its primary purpose is to prevent overcharging of the batteries by shutting off power coming from the solar panels when the batteries get to a certain voltage. It also displays the current battery voltage, the current amps coming in, and the amp hours since the last reset. We record and reset on the 1st of every month to keep track of our electrical usage. The power then leaves the charge controller and goes into another circuit breaker, which also contains a fuse, and then onto the batteries. The wind power does not follow this system. Instead, it comes in from the windmill, which has its own charge controller built in, and into this box, which is another service disconnect, and into the batteries. The reason we have so many of these service disconnects between each component is if we need to work on a particular component, we want to make sure we can de-energize that before working on it. It is also required by electrical code to have switches between each component in an electrical system. Particularly important in a battery and solar system because the batteries can always hold charge, and if we'd ever want to work on the solar panels when there's any light coming in, those would always have some energy being produced. These are lead acid batteries. Each battery is a 6-volt, which has 3 2-volt cells in it. We then connect 2 of the batteries together in series to make a 12-volt system. We have 3 pairs of each of those. Our first set of batteries we upgraded after 5 years, and the second set lasted 15 years before we had to replace them with these. We have to top these off every 3 months with distilled water to replace the water that's electrolyzed away. We also make sure to have a vent pipe to vent that out of the house because it's hydrogen and oxygen, which could become explosive if not vented. For our DC power around the house, we have wires leaving and up to a circuit breaker which distributes the power around the house. For our AC power, the electricity leaves the batteries, which are DC, and into this large circuit breaker box, which also has a fuse in it. It then goes out to our inverter, which converts the electricity from DC to AC, so all normal appliances can be used. We don't keep our inverter turned on all the time. Instead, we keep it in a low power sense mode that detects when there's a need for AC electricity and turns on. In particularly low draw devices, such as LED Christmas lights, this can sometimes be an issue because those don't draw enough power to cause the inverter to turn on. So we have to turn on another light to get them on all the time instead of just flashing. We will also sometimes turn off the inverter when we go on a long trip just to reduce power consumption. We have the inverter in another room because it does make a considerable amount of noise and we want that insulated from the rest of the house. And you'll notice the comparison between the really thick wires that carry the DC power, which is at 12 volts, out to the inverter compared to the AC wire, which is at 120 volts, back to our circuit breakers, which distribute power to the house. What allows us to live with such a small system and not feel like we're limiting our energy use on a daily basis is how energy efficient the house has been designed to be. We only use about 30 kilowatt hours a month in summer and closer to 15 kilowatt hours a month in winter. And the 30 kilowatt hours a day is a use of a typical American household. And though we are concerned to save energy, such as not leaving lights on when we leave a room or unplugging things when they aren't in use, but a lot of our energy savings come from the efficient appliances my parents have bought. The fridge and freezer we have are both specifically designed for off-grid living. They run on DC, which means the inverter doesn't have to turn on when they're using, and they do have extremely thick walls compared to a normal fridge and freezer. They were, however, considerably more expensive than just buying a standard fridge and freezer. But in our system, that's necessary and worth it. We also choose to keep them out in a cold space so they use much less energy, next to none, for the fridge in the winter. That's the main reason why we use so much less energy in the winter. My parents also chose to buy a more expensive but much more energy and water efficient washing machine. That's fairly necessary, as the washing machine is the thing that stresses our inverter the most. And we have to be careful when it's running not to use another high draw device, or else we may blow a fuse. We also don't have a dryer. Instead, we hang our clothes on the line outside, or in the winter, inside. Though we have bought these more efficient appliances, we still can use normal appliances such as the mixer, vacuum cleaner, and we have internet, which we turn off when not in use to save energy. As I mentioned previously, we run both AC and DC power throughout the house. Most of the houses run off AC power, such as our lights, but if my parents were building the house again, they would have made that all DC. The reason? Back when my parents were building the house, you could barely get any DC lights, and those that were available were extremely expensive for very little light output. Today you can find much better DC lighting. Because 12 volt DC is what is used in cars and like campers, if we're looking for small appliances to run off of that, that's where we'd find them, marketed towards boats or campers or sometimes even cars. You can also grab stuff like fans from computers and wire those up directly to the wall to use in the house. You might wonder why, when my parents built the house, they chose to make it off the grid. Though we are environmentally minded, and that's certainly part of the decision, the more important factor was price. In 1995, when my parents were building the house, it would have cost them $13,000 to bring in electricity. And they were able to build the electrical system, including some of the initial appliances such as the fridge and washing machine, for $10,000. And a considerable amount of that money would have had to be spent in a normal house anyways. Even if we were on-grid, with or without solar panels, we use little enough electricity that cost on a monthly basis isn't the big one. It's the upfront cost of setting it up. The other way to go off the grid, which does not require reducing energy use through either efficient appliances or limiting your use, is to buy a lot of panels and a lot of batteries. My parents chose not to go this way because that's much more expensive and it's less environmentally conscious, because all the solar panels and batteries, those require resources to make. So limiting those resources really helps with the environmental impact of setting up the system. If you have any questions about what I talked about in this video, please leave them in the comments and I will try to answer them as best as I can.